Okay, so this is section 1.1 on coordinates and graphs in a plane. And part of this is just to get you used to what the author does in this book. A lot of this is some review, but some of it's new as far as this author's notation. Okay, and there are different ways on solving problems. And if they ask you to do it in a specific method, there's a reason for that. So like one method, they might be to do a problem algebraically. Do a problem algebraically. Now, what's that mean? That means paper and pencil. That means work it out, paper and pencil. And support numerically. Or graphically. So that means like you can do it on graph paper, you can do it on your calculator. Okay? So work it by hand first, paper and pencil, and then check it on your calculator. Okay? They might ask you to do a problem graphically and then confirm it algebraically. So just reverse the order. So do it on your calculator or do it on graph paper and then confirm it algebraically. Okay, and then the third one, there will be problems in the book that if I said to work this problem out by hand, you couldn't do it. Okay? I couldn't do it. Okay? The only reason you can do it is because the calculator can do it. Okay, so that's do a problem numerically and or graphically because paper and pencil paper and pencil methods are impractical or impossible. They are impractical. Whoops, spell it right. Or impossible. If I told you for tomorrow, I would like you to list the real numbers from 0 to 1. It's not going to happen. Okay? You can't list all the real numbers from 0 to 1. Okay? That would be impossible. Okay, now there's some, when the reading and in the directions, if it says sketch a graph, if you see that phrase, sketch a graph, that means use paper and pencil and sketch a graph. Like if I said draw the line y equals 2x plus 3. So just do that on your paper, you sketch a graph. Okay? If you see the phrase graph, now look at this, it's in all caps. If you see the phrase graph in all caps like that, it's all caps. Okay? That means that suggests the use of a graphing calculator. Okay? All caps. If you just see the word graph in lowercase or the phrase draw a graph in lowercase. That means use a method of your choice. So basically, if you see all caps, graph it, that means use your calculator. Okay? The others, like use paper and pencil, or lowercase, use a method of your choice. Okay? Now, that's a little bit that you should get through the reading, that first section. Okay, now, some things that you should also have from having read the section. What is an open interval? Let's look first at an open interval. If we look at that term, open interval, okay, let's look at it on a number line. If I say I want the open interval from -1 to 3, how do I graph it? What's the open part mean? Open or closed? Open. So, and usually I would go above. Open, circle above -1. I want from -1 to 3. Okay, so it would look like that. And you graph anything on the number line, you're going to graph it above it. Okay, so it's easier to see. Okay, that's how you show it on a graph. Okay, if I was just writing an open interval, I said I want the open interval from -1 to 3, and I don't want to do this number line. What symbols does the author use? Huh? That greater than or less than is how we did it in Algebra 2 and pre-calc. Like if I did like x is less than 3 and greater than -1. That's how we did it, like in Algebra 2, trig and pre-calc. Yeah. But what does this author do? Okay, let's take a minute. So on this, for this author, if you're doing an open interval, it's parentheses, -1 to 3. Oops, sorry. Put the wrong symbol. -1 to 3. That parentheses tells you it's open. This parentheses tells you it's open. Okay, so this is how this author is going to write an open interval. In some ways it's kind of confusing because what else does this look like? Looks like an ordered pair. It's like, oh, is he talking order? But that is an open interval. Okay, so if we change this up a little bit and I say I want a closed interval. Okay, on the graph, let's go from -1 to 3. What am I going to do to change it on the graph to make it closed? Instead of an open circle, solid point, right? Solid point. Okay, so that's a closed interval. Okay, now, Brianna, what was the symbol? A bracket. So, that tells you it's closed solid point on -1, closed solid point on 3. Now, if it's half open, half closed, so if I did this, if I said open here, solid here, okay, then this is how the author is going to write it. Okay, the parentheses tells you it's an open circle. The bracket tells you it's a solid point. Make sense? Okay, so you need to look at the symbols. The next thing the author talks about, and you really have already worked with it, and that is the viewing window on your calculator. That's what he's talking about. The viewing window would be like if you did Zoom standard. Okay, the standard viewing window would be like -10 to 10, right? And -10 to 10. So the viewing window is like your X max, X min, Y max, Y min. Okay? The next thing the author goes through is on your calculator, what do those two things on your calculator, what do those control? they control those tick marks, right? They control how those tick marks are spaced out. Okay, like if you do the standard viewing window, X scale is negative or is 1 and Y scale is 1. Okay, so if you want to spread those out, you change the X scale, Y scale. So those control the tick marks. Okay. Okay, and then the most important part, okay, out of this section, because on the test I will say show a complete graph. And we talked about complete graphs last year. But if I said I'm going to do a graph here. Hang on. Okay, let's say I give you this, and I'm graphing this equation. Let's say I give you the graph y equals 2x cubed minus 5. Okay, and I'm in Zoom Standard. Okay, in Zoom Standard, I'm getting this for my picture. Something like that. Okay. Number one, is that a complete graph? Okay. Well, you got to be real careful right here. Complete graph means you've got to show all the x and y intercepts. You've got to show all the max and min points. On a cubic graph is going to look, on a cubic graph it's either going to look like this or it's going to open like this on a cubic graph. Okay? So I would say, okay, I am definitely showing the intercepts. Okay, but I'm not sure right here if I'm showing all the max and min points. Does that little section right there, if I blew that section up, does it look like, does it intercept here and does it do this? I don't know. Is there another max point over here and a min point over here? So you have to zoom in on that point and see if there's a max and min in there. Okay? So complete graph means show all the intercepts. That's all the x and y intercepts. If you want to put all x and y intercepts, and show all the max and minimum points. So if I change this, let me change this to, let's see, if I change this window to, let's say I had the window just like that. Are you seeing a complete graph? No, because you're not seeing that it actually intersects up here. Okay. A lot of times, if you did a cubic graph, let's say I did a cubic graph, and the only part I'm seeing is this, like that. That's not a complete graph. The cubic graph is actually going to do this. And I have to know where is it intersecting the x and y axis. Okay? Makes sense? Complete graph, you show all the intercepts, all the max and min points. Okay? Okay.